Have you ever been caught off guard by a sudden downpour, or startled by a loud clap of thunder, making you wonder just how close that storm really is? Weather can change in an instant, and sometimes those changes catch us completely by surprise. It's a feeling we've all experienced. One moment the sky is clear, and the next, you're running for cover as rain pours down or lightning flashes overhead. Weather shapes our daily lives in countless ways. Sometimes it brings beautiful, sunny days perfect for picnics and outdoor fun, and other times it brings dangerous storms that can disrupt our plans or even threaten our safety. From gentle breezes to powerful hurricanes, the weather is always influencing what we do and how we feel. That's why knowing the forecast is so important. It helps us plan our days, decide what to wear, and even what route to take to work or school. More importantly, it helps us stay safe and prepare for severe storms, giving us time to take shelter or make other important decisions before bad weather hits. Thanks to science, we have incredible tools to help us watch the skies and predict what's coming. One of the most powerful and reliable tools meteorologists use is called Doppler radar. Think of Doppler radar as a weather superhero. It scans the sky day and night, allowing meteorologists to see inside storms without ever having to leave the safety of their weather stations. This technology gives us a window into the heart of a storm, revealing details that would otherwise be invisible to the naked eye. Doppler radar is essential for warning us about dangerous weather, like heavy rain that could cause flooding, strong winds that might knock down trees or power lines, and even tornadoes that can appear with little warning. These alerts save lives by giving people time to act. But how does Doppler radar actually work? It's all about sending out a signal and listening for what comes back, kind of like shouting into a canyon and hearing your echo bounce back to you. The time it takes for the echo to return tells you how far away the canyon wall is. Instead of using sound, Doppler radar sends out invisible radio waves. These waves travel through the air, bounce off raindrops, hail, or even snowflakes inside a storm, and then return to the radar dish. By measuring how these waves change, meteorologists can tell how fast a storm is moving and how intense it might become. Over the next few scenes, we'll break down exactly how Doppler radar tracks storms, helps meteorologists make accurate forecasts, and keeps us safe from the worst that nature can throw at us. When you see those colorful weather maps on TV or your phone, you're actually looking at Doppler radar data in action. Each color tells a story about what's happening in the sky, where it's raining, how hard, and which way the storm is moving. Understanding these maps empowers you to make smart decisions when storms approach, whether it's grabbing an umbrella, securing your home, or evacuating to safety. Knowing what the weather is doing can make all the difference. So, let's dive into the fascinating science behind the forecast and discover how this amazing technology protects millions of people every single day, helping us stay one step ahead of whatever the weather brings. Are you ready to explore the incredible world of weather tracking and see how Doppler radar works its magic? Let's get started on this journey together. Before we dive into the Doppler part, let's first understand what radar is and why it's so important in weather forecasting and beyond. Radar stands for radio detection and ranging. It's a technology that uses invisible radio waves to detect objects and measure how far away they are. This technology is used not just in weather, but also in aviation, maritime navigation, and even by police to measure vehicle speed. To picture how radar works, imagine you're standing in a pitch-black room and you clap your hands. You listen for the echo bouncing off the walls to figure out how big the room is or if there's something in front of you. Radar works in a similar way, but instead of sound, it uses radio waves that travel much faster and farther. A radar system sends out a powerful burst of radio waves from a large antenna, shooting them out into the atmosphere in all directions. These waves travel at the speed of light, about 186,000 miles per second, until they hit something like raindrops, snowflakes, or even hailstones in a storm cloud. When the waves hit these objects, some of the energy bounces back toward the radar. The radar's antenna then acts like a giant ear, catching the returning echoes that bounce back from those objects in the sky. The radar's computer measures exactly how long it takes for each echo to return. By knowing the speed of radio waves, it can calculate the distance to each object with incredible accuracy. If the echo comes back quickly, the object is close. If it takes longer, the object is farther away. This timing is the key to mapping out what's happening in the sky. By sending out these pulses in all directions, and measuring the returning echoes, radar builds a detailed map showing where precipitation is falling, rain, snow, or hail, across a wide area. The spinning radar dish constantly scans the sky, sweeping in circles to create those familiar weather maps you see on TV or online. But it doesn't just spin side to side. The radar dish can also tilt up and down, allowing it to scan different layers of the atmosphere and build a three-dimensional model of what's happening above us. The strength of the returning echo tells us how intense the precipitation is. A strong echo means heavy rain or snow, while a weak echo might mean light drizzle or flurries. This basic radar technology is great for showing us where storms are located right now, but it doesn't tell us if those storms are moving toward us, away from us, or how fast they're traveling. To figure out the movement of storms, whether they're approaching or leaving, we need something more advanced, the Doppler effect. That's where Doppler radar comes in, and it's truly a game changer for meteorologists and anyone who needs to track severe weather. Doppler radar is the next step in understanding not just where storms are, but how they're moving and evolving in real time. So how does this Doppler effect work, and why is it so important for weather forecasting? Let's find out as we move on to the Doppler effect. What makes Doppler radar special? It's the Doppler effect. You've heard it when an ambulance siren changes pitch as it passes by. That's the Doppler effect in action. Doppler radar uses this principle with radio waves. It compares the frequency of the returning wave to the original. If raindrops move toward the radar, the frequency goes up. If they move away, it goes down. This reveals the motion of rain and wind inside the storm. Doppler radar doesn't just show where a storm is, it shows how fast it's moving and in which direction. Meteorologists can predict where storms will go and issue timely warnings. That's the power of Doppler radar. When you see green, yellow, orange, and red on a weather map, you're looking at a reflectivity map. These vibrant colors aren't just for show. They're a powerful tool meteorologists use to interpret what's happening inside a storm, even when it's miles away and hidden from view. Reflectivity measures how much energy bounces back to the radar after it sends out a pulse. The more energy that returns, the more intense the precipitation is in that area. This tells us not only if it's raining, but also how dense the rain, hail, or snow is, and even hints at the size of the raindrops or hailstones. Light green on the map means light rain is falling, enough to dampen the ground, but usually not enough to cause flooding or major disruptions. Yellow and orange indicate heavier rain, the kind that can quickly soak roads, reduce visibility, and sometimes lead to localized flooding if it persists. Red and purple. Those colors signal very heavy rain or hail. Conditions that can be dangerous, especially if you're driving or caught outside. These areas often mark the core of a thunderstorm, where the weather is most severe. Purple or white shades often mean hail is present. Hailstones reflect a lot of radar energy, so these colors are a warning sign for damaging weather, especially for crops, cars, and roofs. Meteorologists rely on these color codes to quickly spot dangerous storms, issue warnings, and track the potential for flash flooding or severe weather outbreaks. Reflectivity maps reveal a storm's structure and intensity at a glance, showing where the rain is light, where it's heavy, and where hail might be falling. This helps forecasters understand how a storm is evolving in real time. They help pinpoint exactly where the heaviest precipitation and hail are falling, which is crucial for issuing timely warnings and keeping people safe. But to truly understand a storm's behavior, like whether it might produce a tornado or damaging winds, we need to look beyond just precipitation and examine wind patterns inside the storm. That's where Doppler radar's velocity data comes in, allowing meteorologists to see the movement of air within the storm, not just the rain or hail. Let's see how Doppler radar works and how it helps us unlock even more secrets hidden inside the storm. Doppler radar's velocity map shows wind speed and direction inside a storm. Green means wind moving toward the radar, red means wind moving away. The brighter the color, the faster the wind. Radar can only see motion directly toward or away from it, not sideways. Meteorologists use these maps to track storm movement and speed. They also spot dangerous wind patterns, like downbursts, which can cause damage even without a tornado. By analyzing velocity data, forecasters issue warnings for high winds and tornadoes. This information is crucial for public safety. Velocity data unlocks the storm's secrets. Doppler radar can spot tornadoes before they touch down. Tornadoes form from rotation inside powerful storms called supercells. Radar detects this rotation, a mesocyclone, by showing bright green next to bright red on the velocity map. This pattern, called a velocity couplet or tornado vortex signature, means air is spinning rapidly. When meteorologists see this, they know a tornado is likely or already forming. Before Doppler radar, tornado warnings often came too late. Now warnings can be issued minutes before a tornado strikes, saving lives. For example, in 1999, Doppler radar gave Moore, Oklahoma, a 38-minute warning before a devastating tornado. Early warnings give people time to take shelter. Doppler radar is a lifesaver. It's changed how we respond to severe storms. Doppler radar is vital for tracking hurricanes as they approach land. Satellites track hurricanes at sea, but radar gives detailed, real-time views near the coast. During Hurricane Katrina in 2005, Doppler radars along the Gulf Coast monitored the storm's structure and movement. Reflectivity data showed the intense eye wall and heavy rain bands. Velocity data measured the hurricane's powerful winds and detected smaller tornadoes within the storm. This information helped forecasters pinpoint where Katrina would make landfall and warn of catastrophic flooding. Real-time radar data was shared with emergency managers and the public. It guided evacuations and life-saving decisions. While Katrina was devastating, Doppler radar's role in tracking and warning was crucial. It's a testament to how far forecasting has come. Real-time storm tracking buys us precious time. Before Doppler radar, warnings often came too late, after the danger arrived. Now meteorologists can see dangerous weather forming and issue warnings before disaster strikes. This lead time is critical. It gives you minutes to get to safety. Warnings are broadcast instantly on TV, radio, and smartphones. Weather apps show you the storm's location in real time. This empowers you to act quickly and protect yourself and your family. Thanks to Doppler radar, tornado warning lead times have increased from 0 to over 13 minutes on average. Fatalities from severe weather have dropped dramatically. The system works silently in the background, always ready to alert us. It's a life-saving network we rely on every day. Real-time warnings make all the difference. That's the power of Doppler radar. Doppler radar has transformed how we understand and respond to weather. It lets us see inside storms, measure wind, and anticipate danger. This technology helps pilots, farmers, event organizers, and emergency managers make critical decisions. The colorful maps on our screens are more than just visuals. They're life-saving data. Radar science keeps advancing with new techniques like dual polarization improving accuracy. We can now distinguish between rain, hail, and even tornado debris. The future of weather watching is brighter than ever. Next time you check the weather, remember the science behind it. Doppler radar is a tireless guardian, always watching, always ready. Consider the science, and stay safe.